Okay, everybody. I'm your Meadow Hare for the day, and welcome to part 2 of the Enemy AI series. And yeah, today we're going to be programming missiles. It's not, well, okay, this movement isn't specifically for only missiles. However, it is what you'd usually see in a video game when there's a missile following you. Like, you could, let me just do a very, very quick example. If you change this to bouncing ball, say, 10 speed, moving at start, you change this to 8 directions, 150 speed, east 4, and then you go in here and say, alright, always make this thing look in the direction of this guy. And let me change the hotspot to the middle. And like here you have sort of a missile following motion, but a lot of times you don't want it to do just that because it just looks bad. Usually what you have is a missile that it accelerates toward the player, and when the player moves, it kind of goes past him and turns back. Alright, that's the kind of movement that I would want anyway. This just kind of looks, it looks amateurish. No offense to anybody if they use that, but today we're going to do something really, really, really complicated. So much so that we have to have horizontal, vertical, yeah, this is where you should start following along. Put all these into this thing. Add, grab, vert, add, NID, and max speed. Okay, so we're going to do all this work in the behavior of this object today, nothing in the actual events. So behavior, let's just say following. And save, and here we go, guys. Okay, so what we're going to do is program this missile. Actually, let me put an example here. We're going to make the missile work like these boos, except for when you look at them, or look at the missile, it doesn't stop in its tracks like that. And after we're done with this episode, I'll post another video sometime of practical application that you can use with this kind of following programming. See, the boos just kind of go past, they circle around, all that good stuff. And I might actually have to refer back to this to complete this, because this is a pretty complicated movement. So let's first just program this one. It's going to say always. I'm going to be doing this really fast, but this horiz and vert add, these are a whole different way of programming, similar to the gravity programming we used for the platforming engines like this one. But it's a little more precise, it's a little more complicated. So what you do is you say, always add to, start simple, add to horizontal, things horiz add. So we're always adding the horiz add to the horizontal. And of course, let's make a separate event for this. Add to vertical, yep, you guessed it, vert add. And another always, these alwayses might change to other conditions, but this is just a start. Add, okay, when this thing's position greater than this thing's x position, meaning it's farther, I'm using my hand to point, and that's not going to do much good. When it's farther to the right than the missile, actually, what did I do? I should have put this thing. When this thing's x position is greater than the missile, add to, horiz add 0. Let's just say 1. 0.1, and of course, oh, see, we don't even need that always anymore. When this thing is lower, when it's farther to the left, we're going to subtract 0.1 from hors add. And when this thing's Y position is greater, or it's farther down than the missile, that thing's Y position, and of course you can just copy it, put lower. Sorry if this is going pretty fast, but you know, you can rewind and replay. This farther down, it's going to add to the vert add 0.1. When it's above, the missile is going to subtract 0.1 from vert add and play it, and nothing happens. Also, take off this movement, make it static. Yeah, nothing happens because, you know, we didn't do anything. So let's go in here and do something. Let's put an on loop. Say on loop V move. Yeah. Let's make two loops. We're gonna have V move and H move. V move, H move. On loop V move when. You know what? Before you do that, say when this thing's value, horizontal, or when horizontal is different than 0, meaning its movement is one way or the other, we're going to start the loop. Where is it? Fast loop, start loop. H move. Enter the number of loops. We're going to start at the absolute value, meaning the positive value of this thing's horizontal times. We're going to do that. Alright, put that above the V move and H move. Start move, yeah. And this is very important. Remember this. Set, this is, oh boy, this is where it gets complicated. We're going to set its horizontal to itself, to the horizontal, mod 1. That's mod 4. Mod 1. Okay, what mod is modular addition, I think, or modular something like that. What it basically does is it takes the number, say your number is 4.4, the horizontal is 4.4. It divides 4.4 into 1, or divides 1 into 4.4, and then takes whatever is left over. Now, this might be pretty tough math for some of you, but 4.4 divided by 1 is going to be, like, 4 with 0.4 left over. The 0.4 is lower than 1, so it doesn't get divided out, and it stays there. So the way this works is you have your hors and vert adds. You're going to keep adding up hors add. So let's say hors add is 0.1. It's going to add it to horizontal. Still not equal 1, so nothing happens. It's not, well, it runs loop the absolute value of the times, but it's not over 1, so the loop runs 0 times. Following me? I hope you're able to follow this. When, let's say a hors add is 1.5, it's going to add that. It's going to be, oh, hey, it's greater than 1. I'm going to run the loop 1 time because it's above 1, but not above 2. And then it's going to mod out, or, take out, divide it by 1. It's going to have 0.5 left over. Let's say your hors add is still 1.5. It's going to add that to the 0.5 you already have. Hey, it now equals 2. Okay, I'm going to run the loop 2 times and divide it out by 1. And it divides exactly. So now you have 0. It starts over. Basically, this makes it so your object can run in between pixels, if that makes any sense at all. It's a more precise movement, and it just looks better overall. Very subtle, but very important. Alright, so now that I've completely blown your minds with that confusing explanation, let's move on. Let's save. Check the time. Okay, it's been almost 6 minutes. Okay, so we have the loop running. On loop H move when horizontal is greater than 0. Okay. Set position. Oh, my own mind is hurting right now, boy. That was a big explanation. To x plus 1. Just like any other loop, you know. Oh, you know what? Let me just simplify this. I'm going to do that really weird equation. Okay. Position, x position, plus... Oh, how does it go again? Man, I really blew my own mind there. Plus horizontal divided by absolute value of its horizontal again. And I think that's how it goes. Alright. So you can do that. Just put the same thing for the y position. Set its position to its y coordinate plus parentheses its vertical divided by ABS per another parenthesis vertical again end to end parentheses. Oh boy. Sorry, excuse me. Tired. Alright. Let's save again, see what happens here. Whoa! And that's pretty cool. It already works. Now see, it's only doing horizontal, and I actually do not know why. Now I know why. It's because I only did the horizontal loop. Alright, let's duplicate that, make it vertical when the vertical is different. Let's run loop vmove abs ABS parentheses, this thing is vertical times, and we're going to set vertical to vertical mod 1, baby. And there we go. Holy cow. It moves really fast though and can easily get out of control. See, now it's, wow, way over there. Now that could be a problem. So we're going to edit these things. We're going to change it, so replace the always with when a horiz add is lower. Wait a second. Reference time, I'm going to go back to these boos and see what I did. Da da da. Da 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 da. Da da da. Da da da. Oh, it's going to get a little more complicated. Alright. This is where max speed comes in, because otherwise it's going to go out of control. See, it just flies around. If you get farther away from it, I mean, it's going to just... And you have to cheese your own missile to keep it from going crazy off screen like this. I can't control it. Alright. So, max speed. Let's change this to 16. And, oops. Didn't mean to do that. Okay. So, we're going to make these things a lot more complicated. So, replace this with when... Oops. When this thing's... Alright, what is this? Oops. Oh well. Horiz, it is horiz. So when this thing's horiz add actually, is lower than this thing's max speed times 1/10. 1/10 allows for greater diversity and precision in setting it. Just trust me on this. I'm not up for any more big explanations. Okay. Wait, what am I doing? Man. You know what, hold on a second while I figure this out. Alright, hey guys, I'm back. Sorry about that. I figured it out. I was just editing the wrong thing. We're going to edit these 4 events right here. So, this is where we add to the horiz and add to the vert. And we're going to change it so that when your player collider, it just doesn't even have a name. Man, I'm slacking today. Let's going to name it follow point. Let's go back into this thing's behavior. When follow point is farther to the right than the missile, and when this thing's horiz add is lower than max speed times 0.1, then it works. And then we're going to copy this into the next one, and we're going to say when it's greater than max speed times negative 0.1, it does that. And we're going to do the same for the vert. We're going to copy it again. Oops. Actually copy that 2 down. This one, event 4 to event 6. And just change this to vert add. And change this to vert add. Say lower and get rid of the negative. And now, simple as that, it should work. Max speed is really low, but it still goes past you and tries to follow and will sway accordingly. Now this is where the fun comes in, because now you can just change the max speed to whatever you want and it'll work regardless. See, 23 changes the max speed to 23. Max speed to 60, it's going to zoom across. Oh yeah. Can go up to 60 miles an hour, baby. But I'm going to keep it at 32. I tend to keep things in multiples of 2, 4, 8, 16, that kind of thing, because the math works easiest with those. And of course, if you want it to go faster, or be more precise, you can always change these to, if you change it to 2.5, 2.5, 2.5, 2.5, and then go in here. It'll, wow, that's really precise. Over precise, in fact. The lower the number you add, the more lazy the missile will be. So I'm going to do 0.0625, and this will make it really imprecise. 0.0625 is 1/16th, I believe. That's another multiple of 8 and such. So, yeah, it makes math very smooth. Yeah, see, now it's barely... it's kind of lazy. A little too lazy. Alright, one last change. I'm just going to make it 0.12. Wait, whoa. 0.125. No, not 0.0125. That would be... oof, that would be one lazy missile. And one last change. Alright, we're all done, right? No, we are far from done, because this only works with one missile. Check it out. You make 2, we're going to have problems. Oh yeah. Those are problems right there. They don't follow. They're both working off of the same loop, so yeah. As you can see, it doesn't work. Alright, so how did I make it so these boos all work individually? You know what, let's save that for next time, because that's going to be a whole nother subject in itself. ID loops and all, this should be enough to keep you busy. So, yeah, this has been the making of missile following, part 1, I guess, with your meadow hare, who is feeling very tired and not very great today, so that's why I've been a little off. But I hope you enjoyed it nonetheless. Thank you for watching, and sorry about that little flub in the middle there. But I know you guys will forgive me for that, right? Alright, that does it for this video. And yeah, see you next time. Hope you enjoyed it. Bye bye.